Hello everyone, and thank you for tuning in. I'm excited to share with you some of the open source data tools for stable isotopes that we've been developing over the last couple of years. But first I want to thank Dave and Ben and Leah for organizing this session on bridging the laboratory database divide in geochemistry. And with that, I will get started. So for a while we've been working on how to make our workflow for processing stable isotope data more reproducible. What I mean by that, given a set of raw data collected by your mass spectrometer, how do we turn that into a final data set that we then would include in a paper or in a presentation in a way that is completely reproducible and faithfully records every step of the way from raw data to final data in a way that does not require any point-and-click operations like those you would need in setting up an Excel sheet or working with a graphical user interface. We found that so-called Jupyter and R Markdown notebooks are a great potential avenue to reach this goal of making our data reduction reproducible. The idea here being that if you're giving a set of raw data files and you combine it with a Jupyter notebook or an R Markdown file, you can generate the final data, or anyone else can generate the final data set just by being provided those two pieces of information. So just for those who might not have heard of these before, notebooks are a combination of writing and inline documentation of your workflow and everything surrounding it, with the code to achieve those tasks embedded within the notebook in between the text blocks. So here is an example of an R Markdown file that has several code blocks highlighted in gray, and those could be in R or Python or a number of other programming languages. The same concept exists for Jupyter notebooks, which support R, Python, Julia, and other languages as well, where you have text and code all in the same document. The big advantage of these notebooks is that they can provide output in many different file formats and thus serve a dual purpose, both generating output in the form of tables in Excel or database entries or images for figures, as well as an actual report that shows you every step that was done in the programming language itself. All the commands that were involved to generate the figures and generate the tables. And those can be output as HTML files or PDFs or Word files or PowerPoint, any number of ways that are useful for what you're trying to accomplish. So as one example, this notebook here is a plain text file just describing what's happening and adding code in between. But you can easily turn this into a so-called knitted HTML document that then provides all of these information as a static document that you could send to a collaborator or attach as a supplemental piece of information to a paper. Likewise, you could turn the exact same document without any changes into a PDF that could serve the exact same purpose. We realized, though, that we missed some of the prerequisites that were needed to make this kind of approach a reality. Namely, we didn't have any open source tools for processing stable isotope data really from start to finish, often not even having a good tool to access the raw data file formats that are created by the mass spectrometers and the software that runs them. And that's where we started creating a number of tools that all are now sort of collected under this umbrella of the isoverse, a broad umbrella organization for open source data tools that are useful in the world of stable isotope geochemistry and all the other scientific disciplines that make use of stable isotopes. In addition to making reproducible data pipelines, we were motivated by trying to create tools that would make it possible to expand instrument uses beyond what's typically possible in the vendor software, because we might be trying to do new kinds of measurements that were not anticipated when the software was first developed. And of course, which is a big topic of this session, the third point here, to facilitate data exchange and make it easier for colleagues to access the information that goes into our processing pipeline. I'm not going to dwell on open source here, just suffice to say We're excited about this potential to draw in community-sourced innovation and have quality control through the community in all the processing pipelines that we develop. The main two parts of isoverse that I want to introduce today are isoreader, which is envisioned as a one-stop command line interface to common isotope ratio mass spectrometry file formats, and isoprocessor, which is a toolkit for all kinds of data processing tasks and data visualization tasks that we often encounter in the world of stable isotope geochemistry. At present, isoreader supports 7 file formats across continuous flow, dual inlet, and scan files from 3 different vendors, including Thermo, Elementor, and Nu. And on the left, you can see an example of a screenshot from the isodat software that runs Thermo instruments. And then the equivalent on the right, produced in 3 lines of code from the original raw data file recorded by the software from the mass spec. Here with isoreader, where you read the file. In this case, optionally, we're converting our time axis from seconds to minutes, and then plot all ions we're interested in this case, 28, 29 for nitrogen and 44, 45, 46 for CO2. This makes it possible to combine data from different instruments. Here is an example of reading in a data file from isodat together with a data file from Elementor, and then converting the raw signal intensities to nanoamps to be able to plot them together and compare them, because isodat reports data in voltages and Ionos reports data in currents. But isoreader is able to extract the resistor values of the operational amplifiers on the mass spec, and thus makes it possible to have this conversion take place automatically. In addition, isoreader makes it easy to export data to other file formats. Here's an example of exporting to Excel, where we can read in a single data file, or we could read in an entire folder, or we could read in every single dual inlet or continuous flow file that isoreader finds on your hard drive and exports it to Excel. Alternatively, you could export it to the Feather file format, which is a shared format between Python and R. In Excel, you would get something like this, where you could export all your raw data, getting your voltages over time, so basically the mass chromatogram, but also information about the sequence data that the user entered, information about the state of the mass spec, the amplifier configurations, and the standard gases that were used here, as well as the data that the actual vendor software calculates based on the raw data, if you want to take a look at that, and export it very quickly and easily. Of course, we are thinking about how to tie this into data export and exchange with community repositories. At the moment, this is not implemented in any way, but part of that is that there are not that many repositories for stable isotope data that really cut across the community. But fortunately, that is. A couple of years ago, John Pauli and Seth Newsom and colleagues made the argument that it is really time for a broader repository for isotopic data. And this is actually now something that is in development. So the IsoBank initiative is headed by Seth Newsom, John Pauli, Gabe Bowen, Brian Hayden, and Chris Jordan. And they were able to raise NSF funding to put together an effort to really implement a centralized repository for stable isotope data called IsoBank that is currently in development. As you can imagine, we're excited about how isoverse could tie into this kind of community effort and help users transmit their data, transmit information about their QA/QC procedures, what standards they used, how they standardized their measurements, and so forth, and are currently in the process of figuring out how that kind of collaboration might look, with a workshop earlier this year before the pandemic hit between IsoBank and isoverse to specifically about that topic. In addition, as Seth likes to say, the elephant in the room, of course, is the metadata, which is the most complicated aspect of trying to create a central repository like that, and is the focus of several of the subcommittees of IsoBank, trying to figure out exactly what kind of metadata each of these subdisciplines actually would find useful to include in a centralized data repository for stable isotopes. And isoverse might be able to help with some of this metadata transmission. We'll have to see exactly how the tie-in is. But I would encourage you to go check out both isoverse and isobank. I think these are all efforts that will help us bridge this divide between the geochemistry lab and the actual data repository that will be useful for the community at large. There's a bunch of functionality in isoverse that I do not have time to talk about in today's presentation, but I just wanted to say that isoprocessor implements lots of different ways to calibrate data, generate calibrations, evaluate how well they do in explaining your variance, and so forth. Different ways of visualizing your data and summarizing your data. And if you're interested, I'd encourage you to check out the isoprocessor library or isoverse in general. We have look for these launch buttons. We have implemented ways to make it easy to launch a Jupyter Notebook or an RStudio in the cloud, so you don't have to install anything locally if you want to try out functionality and just play with it a little bit. We have also implemented a web-based graphical user interface that is part of the ISO viewer library that makes it easy to explore functionality without writing any code, but also generate code examples live from all the choices you make in the user interface. Here in the upper right is the code preview, and you can check this out. We have a demo running on our server. Go to isoviewer.isoverse.org and to the online demo section to find the link. It's not the fastest server, so it might be a little slower than it would be on your own computer, but it's an easy way to check out what's possible through the UI. So with that, I want to finish up and thank you all for listening, and I'd be excited to discuss any questions.